So we will look at what is known as the unit circle and see how it is related to triangles and trig in particular, so right triangles, and what's the relationship. We will later see that the circle, the right triangle, and periodic motion or anything periodic which kind of repeats itself over and over, how they can all be related together. And in this way, it allows us to model and study such phenomena using trig functions and our knowledge of trigonometry. So let's look at this circle. Yeah. So this is a circle, and what is its radius? Radius is 1. You can see it here. Right? And it is positioned with its center at the origin, so 0, 0. And the radius is 1, as you can see. And imagine, consider any point on the circle, right? So I've highlighted 1. And again, the point is like a dot on the circle. Just to make it clear, I made a bigger dot here. And this point can be anywhere on the circle, right? Correct. So we could see, we could place it anywhere. Let's say it's here. At this point, I can make a right triangle with one corner at this point, another at the origin, and third, we can drop a line here, vertical line, and that will make the third side of the triangle. So if we look at this right angle triangle, what is the radius? So the radius is 1. And this angle, I can call it anything. So like we saw last time, let's say it is theta. And this is, what are the coordinates of this point? Let's say they are x comma y. Then what is this height? This is y. And what is, this is x. Now if I try to write the ratios for theta, the trig ratios for theta, let's say sine theta, what would that be? Y over 1, which is just y, right? So y is equal to sine theta. And if I try to find out cosine theta, x over 1, which is just x. So x is cosine theta and y is sine theta. That means on a unit circle, any point on the circle has coordinates cosine theta and sine theta, where theta is the angle the radius connecting that point to the center is making with the positive x-axis. That is if the radius is 1. Okay, so it's not unit circle if we change the radius, right? But let's say the radius was not 1 and it is r. Then how will this change? Sine theta would be y over r. So y would be, yeah, so it is r times sine theta, and x would be r cos theta, right? So that's the only difference that happens. If the circle doesn't have radius 1, it has some other radius r, then the coordinates of a point on that circle become r cosine theta and r sine theta. This is assuming the center is at 0, right? If we shift the center also, then however much we shift, that will get added to x and y, right? If I shift it right by 1, then the x coordinate will become +1. If I shift it up by 3, then y coordinate will be 3 more, so 3 plus sine theta. Right, so this center is, this is A, and this is B, and the radius is R, and this is theta. Then the coordinates of this point are, so it got shifted by A, so A plus R cosine theta, right? And B plus R. If you just move the circle somewhere, the coordinates of the point will become like that. But since we put the center at the origin, that A and B go away. And if we make radius R as 1, then it just cosine theta and sine theta. So the, the 2D graph is divided in 4 quadrants by the axis. This is quadrant 1. This is quadrant 2. This is quadrant 3 and quadrant 4. Right? So now this point on the circle could be anywhere in any of these quadrants. But we already saw this is the unit circle, and the coordinates of that point are cosine theta, sine theta. In this case, that is the theta, right? Is cosine theta positive or negative here? This is negative. And what about sine theta, which is this, right? So this is positive. And if you were here, then cosine theta would be negative and sine theta would be negative. And if you're here, cosine theta is, and sine theta is negative. And here we already know. So what would be tan here? And tan here would be negative, because sine over cosine, so positive over negative is negative. And tan here is, and tan here is negative, right? So we can always figure it out like this. If you notice here, everything is positive, right? Only sine is positive. In third quadrant, only tan is positive. And in fourth quadrant, only cosine is positive, right? So there's an easier way if you want to quickly recall. Here all are positive, so A. Here sine is positive, so S. Here tan is positive, so T. And here cosine is positive, so this is the which ratios are positive in different quadrants. And if you go quadrant 1, 2, 3, 4, it is A, S, T, C. Correct? And you can make whatever mnemonic you want, like some kind of phrase using these letters. For example, add sugar to coffee. Right? Or you can make something of your own. So quadrant 1, all ratios are positive. And all we are just talking about sine, cosine, tan. And the other ones are the reciprocal. So we can figure those out. So all are positive here. Sine is positive in second, tan is positive in third, and cosine is positive in fourth, and the other ratios are negative there. So this is a quick way to recall. But if you're not sure, if you forget, you go back to this. Remember that the coordinates of a point on the circle, unit circle, are cosine theta and sine theta, and you can see which one is positive or negative. And then tan is sine over cosine, and the other three, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tan. So from that, those signs are not going to change if you just go 1 over. Okay, so for sine, You write over 2 for all of these. And it is root 0, which is 0, root 1 is 1, root 2 is root 2, root 3, and root 4 is 2. Right? So that makes this 1 and this one is 0. And cosine goes in the reverse order. So 1, root 3 over 2, root 2 over 2, 1 over 2, and 0. And tan is sine divided by cosine, so 0 over 1 is 0. That is 1 over root 3. This is 1. That is root 3. And that is infinity or undefined. What are the coordinates of this? This is pi over 6. Okay, what is cosine pi over 6 from this table? Root 3 over 2 is the x coordinate and y coordinate is 1/2. And for pi over 4, root over 2 and root over 2. And for pi over 3, 1/2 and root 3 over 2. Right? So you see everything is positive here. But as we go in the other quadrants, we get reflections on some of these, right? Because they're symmetric, but some things become negative. So this one is symmetric to that, and that is 120 degrees, right? 90 and 30 is 120 degrees, and 120 is the double of 60. So pi over 3, 2 pi over 3. This is the 2 pi over 3. And what are the coordinates there? And then this angle is 3 times pi over 4, right? 135. So this is 3 pi over 4. And this is pi over 6. This is 5 times that. So 5 pi over 6. And this one is one more than this one. So 7 pi over 6. And this one is 3, 4, 5 pi over 4. And this one is so 6, 7, 8 pi over 6. And this one is 8, 9, 10. And this one is 2, 4, 6, 7 pi over 4. Okay, so other than these, there are these also there, right? 0 is there, pi over 2, pi, and 3 pi over 2. So what are the coordinates here? So this pi over 2, pi, 3 pi over 2. What are the coordinates here? And here? And at 3 pi over 2, 0, negative 1. Okay, so these are the special angles on the unit circle. And as you can see, all you needed to know were the coordinates or the ratios in the first quadrant. Once you know the first quadrant, and then you can, by symmetry, figure out the second, third, and fourth by looking at which ones are negative and which ones are positive. And we already know how to build the table for the ratios, trig ratios of the special angle.